So let's go back to hypothesis testing. What we do in hypothesis testing, we take some samples and based on that sample we make judgment. In this case of perfume, we took 5 samples and based on that we wanted to make a judgment about the machine, how the machine is behaving, whether the volume has changed or not. That's what we do in hypothesis testing. So in a broader term, what you are doing is you take some samples and based on that sample you judge about the whole population. But then when you are taking sample, there is always a chance of error and we understand that. Whatever judgment you make based on those samples might be right, that judgment might be wrong also. And we put a number against that. Number is how much error we can accept. Earlier when I was talking about p value, I said that p value is 0.05. Anything less than that we will say is p is low. That is something which is the error level which we accept when we are doing sampling and based on that we are making judgment. There could be a situation that you might get an odd sample. You might get a very different sample, unexpected sample, because sample is a sample. There is a randomness in that. You might get a sample and based on that you might make a wrong judgment. You might get 5 samples which are exactly 150, 150, 150, 150, but still there is a chance that machine might have changed in the volume. So for that, let's understand that when we do hypothesis testing, there is always a chance of making mistake. And that's what we are discussing here, the types of error, type 1 error and type 2 error. So if you look at this table, here I have the true state or the nature. This is the fact. The fact could be that machine has changed or the fact could be that machine has not changed. Machine is still producing 150 or machine is not producing 150 cc on average. That is the fact. The fact you can check by looking at all the values. Let's say you take thousands of readings and based on that only you can make a judgment whether the machine is still producing 150 cc on average or not. But once you take some samples and based on that you make a judgment, that is your conclusion. So this conclusion is based on samples. Let's say your null hypothesis is true and based on the sample you support the null hypothesis. You also say that okay, null hypothesis is true, there is no reason to believe that null hypothesis has changed. That is a right decision. No problem with this. Similarly, look at this also. This is also a correct conclusion that when you reject the null hypothesis and actually also the null hypothesis has been rejected because the alternate is true, that also is no problem. So here the sample and the actual truth are same. So then there is no problem. But problem comes that when null hypothesis is true, but based on your sample you reject the null hypothesis. Here you have made the mistake. You have made the type 1 error here. On the other hand, if alternate hypothesis is true, but then you reject the alternate hypothesis, then you have made the type 2 error. So type 1 error and type 2 error. The fact is something else and your judgment is something else. That's where you make these errors. Let's look at the table of these two types of error on the next slide and understand what's the difference between these two types of errors.